Module 1, Lecture B, Setting Up Python. By the end of this lecture, you will be able to install a suitable version of Python on your operating system, configure and use a basic Python-friendly editor or IDE to write code, and run a simple Python script from both the editor and the command line. Installing Python Basics. Downloading Python installer. To install Python safely, go to the official Python website using a modern browser like Chrome or Firefox and type the address directly. The site will detect your operating system and recommend the correct installer for you. Using this official download reduces security risks and is suitable even in stricter computing environments. You can rely on the suggested version as a safe and appropriate choice for your machine. When you download Python, the options depend on your operating system. On Windows and macOS, you can use simple installer buttons that walk you through a standard setup. On Linux, Python may already be installed or can usually be added through the system's package manager, and the official site also provides source files for more advanced installations. Knowing these differences helps you choose the right way to install Python on your device. Before downloading the Python installer, first make sure you choose the version that matches your system's architecture, such as 64-bit or 32-bit, to avoid problems. Check that your internet connection is stable and that you have enough free disk space, especially on older or shared computers. In a lab, you may be required to save the installer in a specific folder or network location, while at home, the default downloads folder is usually fine. Once these checks are done, you can safely download the installer and be ready for a smooth Python installation. Choosing the installer. On the official Python download page, you need to choose the installer that matches your operating system, such as Windows, macOS, or Linux. The site usually suggests an option automatically, but you should still confirm it is correct. You will see several Python versions, and for most people, the best choice is the latest stable Python 3 release. Older versions are mainly for legacy systems, so if you are starting fresh, use the recommended Python 3 version. When downloading Python, you need to choose the installer that matches your computer's architecture, which is 64-bit on most modern systems. This allows Python and its libraries to use your hardware properly and avoid compatibility problems. If you are not sure whether your system is 32-bit or 64-bit, check your operating system settings before downloading. Picking the correct version from the start helps prevent installation errors and performance issues later. When installing Python, choose the installer format that best fits your workflow and gives you enough control. On Windows, the executable installer is usually preferred over the Microsoft Store option for educational and professional use. On macOS, you can either download from the official website or use a tool like Homebrew, which is helpful if you manage multiple versions. On Linux, the system package manager may not provide the latest Python, so many developers install a newer version alongside it. In all cases, use a well-documented and widely adopted installer to make collaboration and troubleshooting easier. Confirming Python version. After installing Python, you should always confirm that the correct version is available on your system. This ensures your operating system recognizes Python properly and does not rely on an outdated or conflicting version. Because macOS and Linux often include a pre-installed Python, and Windows may have leftovers from older setups, version checks help you avoid confusion. Verifying the installed version prevents problems such as tutorials not working, libraries failing to install, or scripts behaving unpredictably due to version mismatches. After installing Python, you should always confirm that the correct version is available on your system. This ensures your operating system recognizes Python properly and does not rely on an outdated or conflicting version. Because macOS and Linux often include a pre-installed Python, and Windows may have leftovers from older setups. To check which Python version your system will use, open a terminal or command line window, such as Command Prompt on Windows or the standard terminal on macOS or Linux, and run the Python interpreter. The system will show a message with the word Python and the version number, including major, minor, and sometimes patch levels. Compare this number with the version you intended to install to confirm they match. If the version is different or Python is not recognized at all, it usually means the installation is incomplete or an older interpreter is being used from the system path. If you notice a Python version mismatch or error, fix it right away instead of ignoring it. Using different versions can cause scripts to fail on another person's machine or make course examples hard to follow on your own system. Verifying and correcting the Python version gives you a stable base for installing libraries and prevents problems when working with others who rely on a specific release. Python code. Confirming Python version. Programmatically check which Python version is running. Then compare the reported version to an expected version string. Based on this comparison, print a clear message indicating whether the current Python version matches what you expect or not. Finally, install the required package using the standard package installation command so the environment is correctly set up. We begin by importing the system module, which lets Python code access information and functions related to the interpreter itself. Here, we mainly use it to check the version of Python that is running. Knowing the Python version is important because some features or behaviors may only work correctly in certain versions. This helps ensure that the code we write is compatible with the environment where it runs. We use the system module in Python to access the full version string, which tells us exactly which Python version is running. This string includes the major, minor, and micro version numbers, along with extra metadata. By storing this complete version string, we can later print it or use it for detailed version checks and logging when needed. We create a short, readable version of the Python version string by using the major, minor, and micro parts from the system's version information. These values are taken from the version info attributes in the system module. The result is a concise string that clearly represents the current Python version, such as 3.9.7. This compact form is useful for quick comparisons or for logging the Python version in a simple, consistent way. For this beginner course, we will use Python version 3 as the standard. This means your Python setup should match this major version to meet the course requirements. Focusing on the major version number is important because it affects compatibility and how your code will run. Using Python 3 ensures that your environment aligns with the lessons and examples in this course. This line displays the complete Python version information for the interpreter that is currently running. It gives a detailed version string, which confirms exactly which Python build is in use. This is useful when debugging or when you need to verify compatibility with certain Python features or libraries. By checking this output, you can be sure you are working with the expected Python version. This code prints a short form of the Python interpreter's version. It combines the major, minor, and micro parts of the version information into a single value. By displaying this value, the code makes it easy to check exactly which Python version is running. This is helpful for confirming compatibility with other code or libraries that depend on a specific Python version. This code checks whether the major version of Python that is currently running matches an expected major version. It reads the major version from the system's version information and compares it to the desired value. If they match, it reports that the Python version is correct. If they do not match, it issues a warning that the running Python version is not the expected one. This code prints a message to confirm that the major version of Python matches the expected version. It serves to reassure the user that their Python installation is correctly set up for the intended purpose. When the major version is correct, the program outputs a positive message indicating that everything is configured properly. In this part of the code, we check whether the major version of Python matches the version we expect. If it does not, we display a warning message to let the user know about the mismatch. This alerts users to possible compatibility issues with the course materials or any features that rely on a specific Python version. As a result, they can quickly recognize and address version-related problems before continuing. This code prints a warning if the major Python version does not match the expected one. The warning helps ensure the user is running a version that is compatible with the course or required software. By giving this feedback, it alerts the user that they may need to update Python to prevent compatibility problems. This script checks which Python version is installed on your system and confirms whether it matches the expected major version, which is set to 3. It retrieves both the full version string and a shorter version for quick reference, then prints them out. After that, it compares the major version of your Python installation with the expected one. If they match, it reports that your environment is compatible, and if they do not, it warns you about the mismatch. This provides a simple way to verify that your setup meets the version requirements for your project. Choosing a code editor. Getting started with IDLE. IDLE is the easiest way to start programming in Python because it is included with most Python installations and works right away without extra setup. It provides a simple place to type commands and see immediate results, which helps beginners build confidence. This basic, distraction-free environment is useful for both students and professionals, and it offers a consistent starting point across different computers. That consistency makes IDLE especially helpful in classrooms and other educational settings where quick, minimal setup is important. When you open IDLE, you see the Python shell, an interactive window where you can type commands and immediately see the results. This instant feedback lets you freely try calculations, test functions, and experiment with language features. Because it feels more like a conversation than formal coding, it reduces pressure and makes it easier to explore. Over time, this interactive practice helps you build an intuitive understanding of how Python behaves, which supports you as you move on to larger projects. IDLE's text editor is designed for writing and saving Python scripts and becomes more helpful as your projects grow. It highlights keywords, automatically indents your code and can catch simple mistakes like missing punctuation. These features support learning by reducing errors without requiring you to manage complex settings. As a result, you can focus on your program's logic and flow while building habits that make it easier to move to more advanced development tools later. VS Code Essentials. Visual Studio Code, often called VS Code, is a free, widely used editor that works well for Python programming on Windows, macOS, and Linux. It is lightweight, yet feature-rich, and becomes especially powerful for Python when you add a few extensions and adjust some settings. When you open it, you see a clean layout with a main editing area, a sidebar for navigating files, and a status bar that shows details like the current file and Python interpreter. Overall, you can think of VS Code as an enhanced text editor designed to make writing, navigating, and debugging code efficient. To set up Python in Visual Studio Code, first install the official Python extension so the editor can recognize Python files. This enables colored syntax highlighting, helpful typing suggestions, and basic error checking, which supports learning and debugging. You can also organize your Python files into folders, and the sidebar will display them in a tree view, making it easier to manage projects and switch between different tasks. Visual Studio Code is powerful for Python because it combines editing, running, and debugging in one place. You can quickly run scripts in the integrated terminal to test changes as you work. It also lets you set breakpoints, step through your code, and inspect variables to better understand how your program behaves. Learning to use these features helps you move smoothly from simple scripts to larger Python projects. Saving Python files. Once you choose an editor or development environment, it is important to save your Python work in an organized and portable way. Always create files with the proper Python extension so the editor recognizes them as programs. Arrange your projects in a clear folder structure, such as a main projects folder with subfolders for different tasks. This organization makes it easy to find, reuse, and share your code later for exams, job applications, or research projects. When working in a code editor, it is important to know how it indicates unsaved changes and whether it supports autosave. Many editors change the file name display or show symbols when there are unsaved edits, and autosave can record your work automatically. Regularly saving or turning on autosave helps prevent losing progress if your system crashes or shuts down unexpectedly. By making saving a habit and paying attention to these visual cues, you can protect your work and stay focused on your code's logic instead of worrying about data loss. As your Python projects grow more complex, it becomes important to name and save your files in a clear, professional way. Use descriptive file names that show what each script does, and follow consistent conventions such as lowercase letters and underscores so they work smoothly across different systems. Keep your work organized by separating experimental code, final reports, and reusable scripts into a well-labeled project folder. This disciplined structure makes collaboration easier, supports version control, and matches common practices in research and industry. Running Python scripts. Interactive Python shell. The interactive Python shell is your first direct way to run Python code, working like a live conversation with the interpreter. You type a command and immediately see the result, which makes it ideal for quick tests, such as checking how a function behaves or trying a new library. This instant feedback encourages experimentation, letting you adjust ideas and rerun them rapidly. For learners, it is especially valuable because it connects what you type to the computer's response right away, without needing to create and save files first. The interactive shell is not just for typing random commands. It is a focused space to refine ideas before turning them into full scripts. You can quickly test data cleaning steps, value transformations, or formulas, and see how they behave on a small scale. This is useful across fields, from engineering to the humanities, where you might verify calculations or experiment with text. Because you work with small pieces of logic, the shell provides a low-risk environment where mistakes are easy to spot and correct. As you gain experience with Python, the interactive shell becomes a powerful companion to running full scripts. It lets you quickly test how changing a function's arguments or using a feature in a tricky situation will behave. You can copy small pieces of your script into the shell to see what they do, which is especially helpful for debugging. Professionals rely on it to test logic, check data transformations, and explore what libraries return. By making the shell part of your regular workflow, you build a habit of fast, experimental problem solving alongside more structured coding. Python code, interactive Python shell. Use Python in a way that feels like an interactive shell, running quick experiments and seeing results right away. Show immediate feedback from simple calculations and basic string changes so learners can connect actions to outcomes. Encourage playful, hands-on exploration with small, focused pieces of Python code to build understanding through rapid trial and error. This comment explains that you do not need to run any pip install commands for this script because it only uses features that come with standard Python. Since it relies entirely on built-in functionality, there is no need for extra libraries or packages. This makes the script simpler and ensures it can run on any normal Python installation without additional setup. We define a function called createGreeting that takes two inputs, a person's name and a temperature in Fahrenheit. Inside the function, we build a friendly message that includes both the name and the temperature using a formatted string. This lets us insert the values directly into the text. The function then returns this message, so it can be used elsewhere in the program. We define a function that converts a temperature from Fahrenheit to Celsius using the standard formula. It takes a Fahrenheit value, subtracts 32, multiplies the result by 5, and then divides by 9. The final result of this calculation is returned as the temperature in Celsius. We store the value 77 in a variable that represents the afternoon temperature in degrees Fahrenheit. This value stands for a typical warm afternoon. By saving it in a variable, we can easily use the same temperature later in the script for calculations or for creating messages. This makes the code more flexible and easier to update or reuse. We begin by calling a function that creates a greeting message using two inputs, the name Alex and a temperature in Fahrenheit that represents a warm afternoon. The function combines these inputs into a friendly, personalized message. We then send this message to the console so we can see the greeting that includes both the person's name and the temperature. We use a temperature conversion function to change the afternoon temperature from Fahrenheit to Celsius. The function takes the Fahrenheit value, applies the standard conversion formula, and returns the Celsius result. We then display both the original Fahrenheit temperature and the converted Celsius temperature, so we can easily compare the two units. We set the weekly hours worked to 40 and the hourly wage to $18. To find the weekly pay, we multiply the number of hours by the hourly wage. This calculation gives the total earnings for the week, which we then display in dollars to show the estimated weekly pay. We use the sentence, "Python feels like a helpful conversation," as a simple example to explore how Python handles text. By working with this string, we can practice common text processing tasks. These include splitting the sentence into individual words and converting all the letters to uppercase. This example shows how Python can easily manipulate and transform text. To work with text, we can take a sentence and split it into individual words. Using a splitting method that breaks the sentence at each space, we create a list where each word becomes a separate item. When we print this list, we can clearly see each word on its own. This shows a simple way to manipulate text by breaking a sentence into its basic components. This code takes a sentence, converts all its characters to uppercase using a built-in text conversion method, and then prints the result. The method changes each letter to its uppercase form, creating a transformed version of the original sentence. The output shows this uppercase text to the user. This illustrates a simple way to manipulate text for formatting or emphasis in applications. This script acts like a simple, interactive Python session, showing basic calculations and text handling. It defines a function that builds a greeting using a person's name and a temperature in Fahrenheit, then prints a message such as a greeting to Alex with the temperature outside. It converts that temperature to Celsius using the standard formula and displays both values. The script also computes weekly pay by multiplying a 40-hour workweek by an $18 hourly wage, and then demonstrates string manipulation by splitting a sentence into words and converting it to uppercase. Overall, it encourages experimenting with small, focused pieces of Python code for numbers and text. Running scripts in editors. When you move from typing short commands to writing full Python programs, it is best to use a code editor or an integrated development environment. These tools let you write and save your program, then run it with a simple button click. The editor automatically calls the Python interpreter, sends it your script, and shows the output in the same window. This setup allows you to focus on the logic of your program instead of dealing with command line details. Using an editor to run your scripts is helpful because it keeps your code, output, and error messages in one place. You can write a program, run it, and immediately see the result without switching tools. If there is a typo or logic error, the editor points to the exact line and shows a message in the same window. This quick feedback makes it easy to adjust your code, rerun it, and experiment as you learn. As your Python scripts become more complex, using an editor or integrated environment can make your work more efficient. These tools let you choose the Python version, set a working directory, so data files are easy to access, and pass inputs directly within the editor. You can, for example, start your scripts in a data folder and rerun them quickly as you refine an analysis. Many editors also provide terminals, interactive consoles, and debugging modes that let you pause execution, inspect variables, and step through code. Together, these features support faster, more powerful programming workflows. Running scripts in terminal. Running a Python script from the terminal is important because it matches how Python is used in real professional environments. It gives you more direct control over how your program interacts with the operating system, including managing files and tools. The basic idea is to move to the folder that contains your script in the terminal and tell Python to run it, which works similarly on Windows, macOS, and Linux. Learning this skill prepares you for working on remote servers, automating tasks, and integrating Python into larger workflows beyond a single development tool. Once you are comfortable using the terminal and moving between folders, running a Python script is simple. You just navigate to the folder that contains your script and use the Python interpreter to execute it, much like giving a colleague instructions to follow. Any output, file changes, or prompts from the script will appear directly in the terminal. For example, a data analyst might run a script to process survey data and watch the terminal show progress and completion. This way of working is minimal but powerful, providing speed, precision, and repeatable results. Running Python scripts in the terminal enables powerful workflows that go beyond what most editors offer. You can schedule scripts to run at specific times, chain commands so one program's output becomes another's input, and pass different arguments for different tasks. This lets a biology student automate genetic sequence analysis overnight, or a web developer run scripts on a remote server. All of these uses rely on the same core idea: using the terminal to execute Python scripts reliably and efficiently. In this lecture, you learn to install a suitable version of Python on your operating system, configure and use a basic Python-friendly editor or IDE to write code, and run a simple Python script from both the editor and the command line. In the next lecture, Lecture C, we will go over first Python steps. Thank you for your attention. See you all in the next lecture.